In this lecture, we're going to build on top of what we did in the last two previous lectures and make our coroutine type support the co-return operator. Now, to support the co-return operator, all you have to do is put in return value methods in your promise type. And this is what you see here. The first one that is going to take a parameter is going to actually be used when you pass an operand to the co-return operator. So this is going to be used, for example, if you have an operand to the co-return operator here, for example, co-return 4. If you do that, the compiler is going to pick up the return value method and it is going to grab the parameter and stick that in our m value member variable. Pretty similar to what we did with our yield value method, but this is not going to return anything because we don't really want to suspend. This is a return statement which is going to throw us out of our coroutine function. We also have a return value method which is going to be used if we do something exactly like this. So we don't really want to return anything. All we want is to jump out of the coroutine function. So the return void function is going to be picked up by the compiler and be used from our promise type. And you have to make sure these methods are variable if you want to support the co-return operator in your program. If we set up something like this, our code is going to work. So we are going to pose and return values as a result of the co-yield operators here. And when we hit co-return here, we're not going to return any value. So if we try and print that, we're going to get a bunch of compiler errors, or we're going to get a junk value, which is really not what we want. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are back in Visual Studio Code. This is the last project we did, and I want you to see the compiler error we had from the compiler from Microsoft. And this compiler error was saying that we need a return value or a return method in our promise type for the code here to compile. And I think the reason we have this kind of error is that the compiler is going to insert an implicit co-return operator if we hit the end of our coroutine here. And for this operator to work, we need return void implemented, and we don't have this as of now. So we're going to solve this problem in this lecture here. So we are going to do this in our co-return project. So let's grab the code from the last lecture and use that as a starting point. Let's copy this into our new project, and we are going to crack this open and use this as a separate project because we don't want to splitter or put junk in our last project. And let's try and compile this, and we're going to see that this is not going to compile in our compiler from Microsoft. Let's try to use that. This is going to tell us that we have a bunch of errors. We can't really use the co-return operator. And the reason is we don't have a return void method that is needed by the compiler to support this operator in our promise type. Let's make sure this is also building or not building in the compiler. From GCC, you see that we have the same problem here. So let's put in our operators. The operators are going to be ridiculously simple. So let's put them in. We're going to say return value. This is going to be called if we have an operand to our co-return operator. And return void is going to be called if we don't have an operand, just like we have in our do work coroutine here. Now that we have this method in our promise type, the code here should compile because the coroutine statement here is going to be reusing our return void method to throw us back out of our coroutine. Let's make sure the code here compiles, and I think we should take out the code because we want to follow these things step by step as we resume and see things happening here. We can pass this through the compiler and see if this actually works. Now the build is going to be good. Let's see if the compiler from Microsoft is happy. And we have a bunch of errors and I don't know why. And from the perspective of the compiler from Microsoft, we cannot contain both return value and return void. This is really bad. So why is it? I don't really understand why we have this limitation from Microsoft. But if we want to use this compiler, we can take out our return void, for example, because it's not returning a value. So let's take this out and make the compiler happy We're going to pass this through the compiler again and see if the build is good. Now we have a bunch of warnings, and what is the warning saying? Now the compiler is saying we don't have return void, and we are returning here, trying to use the return void function. Let's try to return a value here and make the compiler from Microsoft happy. So we're going to pass this through the compiler again. And now the build is good. I think it is a good practice to make sure your code compiles across different compilers. That's why I am taking out the return void operator, because I can just return a junk value and ignore it in our C++ program. And the code is going to compile across all these compilers. Let's make sure GCC is working. We're going to pass this through the GCC compiler. It is going to be happy. Everything is going to be fine. Now we can try and use our code here. We're going to hop over in the main function. We're going to create an object of our coroutine, and we're going to be resuming. This is going to be pausing on first call because of the return type we have in our initial suspend method here. So to see anything happening, for example, to see this message, we need to resume our coroutine here. So we are going to do just that. We're going to resume it for the first time. This is going to print the message, and we will hit the co-yield statement here. This is going to pause execution and store information about our coroutine on the heap, as we have seen. Parameters and local variables are going to be stored in, and the next return point is going to be stored in. And that's going to be this location here where we hit co-yield 2 here. Let's pass the code through the compiler, and we should see a 1 printed out. We can do that and use GCC. This is going to do. The build is going to be good. We can clear. Let's make sure we clear properly. We're going to bring up a terminal window, and we're going to clear and run rooster. We will see our 1 printed out. This is really good. We can put a separator and resume again, just like we did in the last lecture. We are going to be resuming from co-yield 2 here. This is going to run the code here. It is going to pause and return a 2. And we will see this 2 printed out here. And we can actually ask the coroutine if it is done. This is good practice. So let's do that. Coro done. And we will print the information here. We're going to take task mhandle, and we're going to call the done method to see this information. And we can close the left sidebar here. It is just eating up space that we need. And let's say stdc out std bool alpha to see our information in the form of true and false. And we should see a 2 printed out, and our coroutine should tell us that it is not done yet. So this is going to be a false. This is what we expect. We can pass this through the compiler. The build is going to be good. Let's clear and run rooster. We will see that the coroutine is not done yet. Our value is going to be a 2. And if we resume again, we will hit this line and pause, and the value is going to be a 3, and the coroutine is not going to be done yet. So let's copy this. I think this is going to save us a few seconds. And we're going to pause for the 3rd time. And we can take out this message here. And we're going to print the value and see if our coroutine is done. Again, this is going to resume from this point here. We're going to say 3, and our coroutine is not going to be done. Let's pass this through the compiler. The build is good. We can clear and run rooster. We will see a 3, and our coroutine is not done yet. We have hit this point. This is where we just paused. If we resume, we're going to hit the co-return statement. And this is going to take out our coroutine function here. We're going to return a 4, but our coroutine is going to tell us that it is done. Let's copy this line and put this in again. We're going to go down and ask the coroutine if it is done, and we're going to get the value that we are co-returning and print that out. We can pass this through the compiler. The build is going to be good, and if we clear and run rooster, we're going to see that we will get our value. So we are returning a value. You see that our return value method is being called. You see the message here, and we will see this value printed out. And if we ask the coroutine if it is done, it is going to tell us, yes, I am done, because the coroutine has run to completion as a result of this code return here. And this is how you can support the code return operator in your C++ program. Now, you have seen that the compiler from Microsoft doesn't like it if we have the two return value methods. If we pass this through the GCC compiler, you're going to see that it is going to work exactly as we want. The build is good. We can clear and run rooster. We will see our data printed out. But if we put in all the two operators, for example, if we put in the return void method here, we're going to see that the compiler is going to freak out. The compiler from Microsoft, I should say, and I don't really know why. I think it is logical to have all these operators supported for your coroutine, but I don't know the reasons they had to disable this. So if we don't want to pass an operand to our coroutine operator here, we have no option but to take out the return value method here, which is going to take an operand. So we're going to take this out, and if we build, our code is going to work, but it is going to co-return, but it is not going to return a value. So if we try to access this value here, this is going to be a recipe for disaster because we are not really returning a value from our coroutine. Let's try to compile and see what happens here. We're going to pass this through the compiler from Microsoft. It should be happy, so the build is good. We can clear and run rooster, and we're going to see that if we try to print our value after we return without really returning anything, we will see the data that we previously had in here. This is going to be really bad. Okay, so this is really all I had to share in this lecture, showing you how the co-return operator works. To support it, you have to either put in return value or return void. We have seen that the GCC compiler actually accepts our code if we put in all these methods, but the compiler from Microsoft is freaking out if we have all them in. So if you want to support the compiler from Microsoft, you have no choice but to choose one of these methods, and that's going to be a choice you have to make in your C++ program. We are going to stop here in this lecture. In the next one, we are going to use all the information we have now and set up a generator we can use to generate numbers lazily and print them as we need them. And you're going to see how cool that is. So go ahead and finish up here and meet me there.